Dear attendees, let's move on to the bronze partners of this year's conference, Velebit AI, who have significantly contributed to achieving everything we envisioned. This is another milestone in our long-standing collaboration, and we hope there will be many more. Mladen Fernezir, co-founder and lead data scientist at Velebit AI, will talk with the talk AI Search Solutions for Online Marketplaces, New Experiences and Technical Aspects. We'll delve into cutting-edge AI-powered search solutions. He'll discuss how multimodal approaches are enhancing search functionality and shaping the e-commerce experience. Mladen, the stage is yours.
Hi everybody, and thanks for the nice introduction. Happy to be here as partners for the conference, and also me as a speaker. I'm glad to be here. Okay, so the topic for today, we'll be talking about new AI search solutions. So there are many things happening now related to search, and it will also influence online marketplaces. Okay, so just to tell you briefly what I want to convey here. Okay, so generally I want to share with you how we see at Velebit AI, and me personally, what's happening, what's the trend with search especially, but other things as well for AI commerce experience. So the experience for people will change. This is happening now. And also for the main parts, search, that's from the buyer's perspective, but I'll also touch it a bit more from the speakers, from the seller's perspective. Because, I mean, if you enable searchable product listings, if your products are easier to find, well, that will also help the main use case of your buyers doing the search. And also for the final part, I'll go a bit more technical, just to highlight what are the important trends, aspects, how those things are done, and also what's quite important these days for search in general. Okay, so here's also briefly the content. We'll see all those things along these lines. Okay, so first of all, just to tell you a bit more about Velebit AI and myself. So I'm a lead data scientist at Velebit AI. I've been doing machine learning, data science, all of that for the last 10 years. So AI, as we know, it's an umbrella term. So there's a bunch of things under that term. So we've been doing this for like 10 years. Also modern things like LLMs. But there's also a lot of, let's say, traditional machine learning on computer vision, NLP. It's deep learning also, a lot of deep learning here, especially for those things that we do. So we've been working on many different domains, both for startups, both for corporations. The thing to tell you about ourselves is that we are now mostly an AI agency, so like a software agency, but focusing on the machine learning and data science solutions. But as well, what we started with, it's online marketplaces. So in parallel, we are also offering many solutions for online marketplaces in particular, and today I'll be talking a lot about that. Maybe just to mention some of our clients. So Willhaben in Austria, it's an online marketplace. Njuškalo in Croatia. And also here in Serbia, we had some consultancy work with the Inspira group, so they're also doing work for online marketplaces. Okay, so just to move on. Basically, okay, so the current e-commerce versus the future, and when I say the future is actually happening right now. So this is something that's happening, and okay, there are some challenges with let's say the traditional e-commerce. So there are many of those challenges. You sometimes can't find what you look for. It's not intuitive. It's not user friendly. All of these things are changing, and it will improve. It's happening right now, and even more so in the future. So, okay, what I want to do here, we have two perspectives. So we have buyers and we also have sellers, right? So the search experience, of course, that's from the buyer side. And like I said, also if you improve product listing, that will also help the search case for the buyers. Okay, so first of all, I'll talk about the use cases and the solutions that we have in Velebit AI that are directly related to the buyers, to the search experience. Okay, so search by image, AI fashion search, interactive chat-based search, something that we recently developed, and also something we have from before, real-time object detection and search. So those are the four use cases I'll go over. And let's start with the first one. So search by image, visual search. So this one I think is particularly fun to me. I mean, this is something that we did back in 2016. We were proud to receive the Best Poster Award at GTC NVIDIA. So that was quite early back at the time. So this was, as far as I'm aware, the first solution for online marketplaces. So this was before eBay had it, all the big players. So something that we developed internally as a research team. So at the time we weren't Velebit AI, so we were working in a corporation. So that's something that we started doing at the time. Later on, we started our own company. So those were the early days. And here, okay, so what's the idea? I mean, it's a basic idea. Nowadays, it's quite common. You have an image, and you want to search for similar images. So that's something that you take for granted maybe these days, but back then this was something quite new and interesting, especially for Willhaben. So for fashion, this is something that's a useful feature. Just to say a bit. Just to say a couple of technical bits here at this point. So what we used was a custom convolutional neural network. So this network at the end gives you feature descriptors. You train it for some other task. You can train it on multiple tasks like category prediction, attribute prediction. We did a bunch of things. And on top of that, we also added some custom tweaks. So it wasn't just the final vector that you get from the network. So this is what many are doing still today, just taking the final representation that you get from such network. We did a lot of other things. We added some some features for color, some features also for attribute, for patterns. So this is something that we added just to improve the experience. And also what we did back then, we used binary vectors. So binary vectors are especially good for production because you can do fast binary vector comparisons. So that was the early days for us. And even so, even though it was so early, we got good solutions with that, and the client was happy with that. Okay, so to go to something more recent, so AI fashion search. So this is something that we recently developed, and just to explain it more a bit. Okay, I don't have the pointer maybe working, but okay, so. You can't read it here, but it says casual chic linen pants. Okay, so imagine you're searching for something like that. And also to make it more difficult, let's say you have images, but you don't have any tags. Okay, so it would be easier if you have image tagging, then you could match your query with the tags. But here we just have images. In some cases you don't have it tagged. And basically what we're doing here, we're using a multimodal model. So what this means is that we can take the input query, so the text that we have, and we can convert that into a vector representation. So that's something that's typically done. And we also take those images and convert them to a compatible vector. So the key thing is here that you have vectors that are mutually compatible. There were talks today also about clip models. So it's basically a variation of that, where you have vectors which are compatible. So vectors in the textual space, in the image space, you can compare them. And so the user experience is that you can just start with the query, and then the query can be matched to the image that corresponds to it. So that's the solution that we have here. Also, okay, for the next thing, so this is quite similar. It's something that's a follow-up to the previous solution, you can imagine that, okay, you could start with a query, right? You're searching for something, but then, okay, you get some results with the first system that I mentioned, and then, okay, maybe you want something different, right? So you want some changes. So find me a white boho dress, okay, maybe add me some blue details, and let's have it differently. So for this solution, what we're doing, we're using an LLM to parse user inputs. So basically, the LLM is checking the entire conversation, and it's quite an easy, effective solution. Basically, what we're doing, we are constantly updating the search query, like in the previous use case, but we update the query based on what the user said in the chat. So that's the main idea, and also what we're adding here, we are also adding, we have a special model to detect brands from text, and also we are connected to the database, so we also recognize size. This is something that's new in production. We will also soon add other features to the extraction of attributes. So basically, you can also add some attribute extraction. You can filter by that, and then you have again this multimodal approach where you search for similar items and you iteratively update this prompt. So that's the idea here. Okay. And now for the next use case, this is something that we also have for a while. So that's something that's useful both for the buyer and the seller side. So you can imagine that you have a cell phone and you move around, and what you will get is, okay, let's say we've pointed to the mobile to the chair. You'll see, okay, that's actually a chair. You will get category prediction, you will get price range, you will also get when was it last sold. So this is something that we developed, and it's useful both for the buyers, if maybe you want to buy something similar, or maybe you want to sell your own chair. So this is a use case that's useful both for the buyers and the sellers. And a bunch of things here. You have to solve object detection, so it's deep learning to get that, and a bunch of other things that you have to do on the technical side to have such a use case. Okay, so to move on to the seller side, so what can we do to enable our product listing to become searchable? So here we have three use cases that I want to show you that we have in Velebit AI. So attribute and product tagging, related to that categorization, and also duplicate detection. So this is also something that's useful to have your items more relevant and with less clutter. Okay, so for the attribute and prediction tagging, so it's something that you might think it's useful, and okay, you can use convolutional networks, nowadays transformers. Transformers are also now in computer vision, so that's also typical technology. What you can do, you could predict various things that are useful both for your sellers and for buyers, like fabric pattern, brand, colors, sleeve length, things like that. You can add attributes which are useful. You could then also use simpler search solutions if you have tagging like that. And also, what we did recently, we have it as an API service for color detection and fabric pattern detection. So this is something that we recently also have as a service, just to use it as an API. But generally, we develop a custom solution for a customer so that we add the tags what the customer wants. Okay, so that's one solution related to that. So this is something that in some cases could be more tricky than it seems. So it's basic categorization, right? But as we know, if you're in the industry, you could have literally like thousands of different categories. It could be a bit messy. So typically like 2,000 categories. There is also a categorization tree, so there are multiple levels. And for this, we have different solutions. We have classification only from text, classification from images, classification from both. We also have the extra system, which will enable to maybe lose some specificity if the model is not certain. So in some cases, if you have multiple categories, different levels. You could say something that's less specific. You don't have to be exact. This is also useful for the end customer, even if you don't predict the entire fine-grained level of, let's say, 2,000, or in some cases we had 3,000 categories. It could be a mess. Okay, so that's also something that's useful later on, either for search and also when actually you have to place those items for sale. Duplicate detection, also something that's quite useful. It's based technically again on vectors. You get some representation of images, and then you can compare those vectors to find similar images. Basically, it's also rather related to image similarity, but this is a different type of similarity you want to detect if there are some changes to the original image. This could be useful if, let's say, for real estate, maybe some agencies giving similar ads of the same retail. So this is also something that's quite often useful to be able to find such duplicate cases. All right, so that's been briefly about every use case. I mean, of course, you can ask me later, and I'm happy to talk about each of those use cases in more detail. Now what I want to tell you about is, okay, what are the trends? What are the general technical aspects of search? So what's happening? So I've told you about our use cases, so the things that we've developed. We're also looking into what's happening now, what we can add, what we can improve, and there's a bunch of things with search, so this is pretty active right now with the approaches. Okay, so again, I mean, there's a bunch of issues that we want to address. Okay, so I mean, if you have textual search, maybe you're not getting quite right what you're asking for. Maybe you won't get the match with the exact keyword. You could have spelling mistakes. You also want to add filters, which you might not have automatically. So ideally, what you would want is, okay, you have some search query, and then some AI system, machine learning, whatever, to recognize the filters automatically so that you don't have to manually fill them. So there's a bunch of things that would be useful to have. And okay, so what's happening? I mean, generally as a trend, okay, so we had keyword-based search. We also have it today. It's still relevant for interpretation and for exact matches. Then, okay, so we moved on to contextual search, semantic search. We want to recognize the intent. Basically, this is vector search. You have vector representations of your text or images, and then you can capture the semantics with this approach. And also what's happening today as a next step, we have multimodal search. So now, okay, we want to include, yes, images even before, but we will also want to add sound, right? Also maybe video, if we are searching for videos directly. So that would be the use case. So those are the trends, and all of those things are active together. So it's a bit historic like this, as I'm showing it, but it's also combining all of these things together in the current solutions. So briefly, multimodal AI. So I'll just highlight some typical keywords. So what's important for the technology? Vector databases, vectors in general. So this is something that's now quite popular. In general, hybrid search. So combining different types of search together. So that's quite a common theme. For the technology, transformer models, convolutional neural networks, that's also the core technology, what you need to even produce those representations. In the end, you want vector representations. So that's deep learning that you have from before. And also what we have, okay, we have LLMs. That's something that today we call AI, because you don't have to train your model, gather the data. Often you can use the LLM to give you some useful information. Like, for example, we're using for the chat experience, we have the LLM parsing the prompts and understanding what the user wants. Here, what I'm also showing, this is architecture from Google Gemini. So why I'm showing this is that because typically, how people started doing things is, okay, you have separate models, like separate model for text, separate model for images. You get vectors from both, and then you combine them, somehow you make them compatible. But basically, you have two different models. What they're doing here is they're using different modalities in the same model. So that's the big difference here. So you could have text, sound, images, video. You could have representations of that. One transformer, and then you could have, in the end, generation. Decoder is for generation. So image generation, text decoder for text generation. So what I'm highlighting here is that we are moving on from separate models for each modality to something that can work with more modalities at once. So this was something that will enhance the capabilities. Okay, so a bunch of things on this slide. I know that you can't read it from the back back seats, but let me just go over. Okay, so what do we want to build and do? So that's the first thing. There's a bunch of techniques, but let's just go over what we might want. Okay, so text queries, so that's a given. We will start with that. And let's say we want to search for images and text. So that's something that's quite common. Okay, maybe for the next step, like we also have it in one of the use cases, we could also have images as queries, right? So you could have some starting image, and let's find me something similar. Later, we will also want more modalities. Let's say voice. So that's something that we'll want for sure. Again, okay, as I mentioned, it would be quite useful to extract possible attributes and categories automatically from user queries. So you could have different types of filters like brands and size and whatever. It would be quite cool if you can get that automatically. So that's something that we would want. We also want to match that. Maybe the extraction is not quite what you have on your site if you're an online marketplace. So you need to do some type of matching of the extracted attributes and your own filters. And okay, we want semantic intent, so that's what vectors do. We want to understand what people are searching for, even they don't have it explicitly in keywords. Hybrid search, what I mentioned, so a bunch of different types of search together, also with different modalities. And I'll mention, okay, in detail how those things are done. So, but just as an intro, what we want to do, what are the capabilities that we want to have. Okay, so let's say something about attribute or category extraction. So we want to fetch different attributes. And what we could do. Okay, so one thing nowadays, what we can do is just ask LLMs. So LLMs are quite useful to understand things. So maybe we can get, okay, tell me what's the brand. Potentially we could just use LLMs for things like that. Or maybe just extract me some attributes from text or even from images with today's multimodal LLMs. Okay, so that's one thing. You could train your own models. When I say traditional ML deep learning, so that's anything before ChatGPT, basically. So I call it now traditional machine learning, traditional deep learning, in the sense that you actually have to do your own models, data collection, training, all of that. So I have to also say this is all well alive, because you will often want to have small specialized models. And you won't always just use ChatGPT or something similar. There are other techniques, attribute category embedding, similarity for matching. So basically, again, if you want to match different types of categories, attributes, maybe you have something a bit different on your online marketplace, you could do embeddings and then match what you extracted with what you have internally. Traditional search is also alive, BN25, something that's related to keyword search. It's still useful. One thing that's a bit more recent, it's called SPLATE. It's sparse embeddings. So what I was talking about previously, it's dense embeddings in the sense that you have like a large vector and you have a big series of numbers. That's dense embeddings. Sparse embeddings are larger. And they have a bunch of zeros. So basically, what you could have here, I'll explain it here. Let's say, okay, what's the use case? You have some query. Do any large monkeys come from the jungles of Indonesia? Right. So that's the query. And we have some document. Orangutans are native to the rainforest of Indonesia and Malaysia. Right. And so you could have, imagine, like a big sparse vector, which is as large as your vocabulary, and you just have ones where you have your term, like, okay, orangutans, one native one, rainforests, so on. So that would be a large sparse vector that's basically trying to do keyword extraction. So that would be similar to keyword extraction. But the neat thing here, what we can do, is that there are models which can tell you what are similar words. So for example, we have here Indonesia. But okay, there are some countries that are similar, Java, Borneo, Malaysia, or maybe for jungle, like similar is rainforest lands and so on. So it would be useful to get similar words, and also what's important, you would want to have some model that's doing that for you, so that you have to do a bunch of rule crafting and things like that. So it would be great if you could also learn something like that and have your model doing expansion. So what we're talking here is about query expansion. You're doing, again, something that you want to do with keyword search, but the trick here is that you expand both the query and both the document with similar keywords. So that's the idea. And technically, I'll just glance over it. This you can ask me later. There is a model called BERT. Technique is called mask language modeling. And basically what's happening here is that, okay, you put a mask here initially for some word, and the model will try to guess, okay, what was the masked word? And you will get signal for similar words, like forest, jungle, lands. So this is all similar to rainforest. You mask, let's say, rainforest. The model is able, it's trained like that, when you mask the input to predict signal for similar words. Okay, so that's one thing. Okay, to move on to the next thing, what we want, semantic intent beyond keywords. So that's all about dense vectors, specialized databases. You also want to have what's quite important today, efficient nearest neighbor search. So many databases support it now, so that's something that is quite useful. Another thing that's useful, sentence performance library. This is something that can give you similar vectors, something that you need. This is done with the by encoders. And also what they have, it's useful cross encoders. Basically, you don't have vectors here, but I have it on the next slide briefly. What you can do with the cross encoder, you could have, let's say, some query, some text, and this model will tell you whether those texts are similar. So this cross encoder part is especially useful for re-ranking. You could have cases like, okay, this is my query. I have a bunch of sentence B candidates. They came from some search. And then you could ask a model like this, okay, score me each combination. And we can do re-ranking with such models. So that's something that's quite useful for the search experience. Almost near the end, different types of search together, hybrid search. So basically, it could be different modalities, but even with the same modality, you could have different types of vectors, like sparse vectors, you could have dense vectors, you could have BN25. You need some ways how to merge all of those things together. There are different approaches. One approach is, okay, let's do it sequentially, maybe one after another, so one for the retrieval, other for the re-ranking. Or you could do it in parallel, and then you do the fusion. You somehow match the results together. So that's the idea here. And I just have it as a illustration. Okay, maybe just briefly about this one. Okay, you have results from one search engine, the other search engine, and then you just somehow have to rank the documents, like document 3, document 2. You have to check, okay, it's called reciprocal rank fusion. Basically, if some document is high with the first search engine and is high with the second search engine, you combine their ranks. So you check the ranks with each result, and then you will get the combined rank scoring. So basically, that's the idea here. With this fusion approach. The other approach, and just again what we're talking about here, okay, so let's say you have one model, okay, a clip model.
Mladen?
It's returning.
I'm sorry.
Yeah.
Can I just please you to wrap up?
Yeah, that's basically my last slide. Yeah, sorry. Okay, so the clip model, let's say the clip model returns you images, right? Similar images, and you have some scores. The other one returns you text. But those scores could be quite different, and you could have a bias from one model if, let's say, this one textual model gives you high scores. There are ways of renormalization before you combine those scores. You can renormalize it, you could take into account the extremes in those distributions, and you will get then the final scoring. So basically, yeah, a lot of things to tell you about. This is the last final conclusion here. Generally, okay, the experience is changing, right? So we see here a bunch of things, techniques for the search. So for the search, it will become more personalized, more user-friendly, and basically it will become a lot closer to like coming to the real store, and maybe you have a personal assistant that's telling you what to do. And with this, I will stop. Thank you for your attention and time, and I'm open for any questions, either now or later. You can catch me.
Thank you so much, Mladen.